It's going to be a short class. Because I really don't feel like teaching today. I don't know, I guess I'm just having a lazy day. Anybody ever have lazy days? Yeah, every day. All right, let me talk about the complement first. Complement is spelled two different ways, and I can't remember in statistics how it's spelled. I think it's with an E. But the complement is what makes up the whole. Now that's a Hubertism definition, but about as simplistic as you can get. If I tell you that one answer is true, then what's the complement of true? False or not true. Complement of 0, 1. What's the complement of 35 cents to $1? 65 cents. What's the complement of 15 students in a classroom of 30? 15. What's the, but anyway, that's the complement. Complement is what makes up the whole. If you're given this, what makes up the other half? Or the other part, whatever you want to call it. Let's say the other part. Now, you can use this to your advantage. In other words, if a question asks you, what is the probability of one or more houses voting a certain way? One or more homes voting for a variance or whatever. Then what you can do, if you do one or more, let's say there's 8 homes. Right? And you're doing the probability for one or more. One or more means 1, 2, 3, 4, 5, 6, 7, and 8, right? Or you could just do the probability of what? 0 and subtract it from 1. So that's how we can use the complement. So if we say that the probability of 0 is 0.32, then all we have to do is say, okay, if we want this, then that's the 1 minus 0.32, which is the probability of 0, and that's equal to 0.78, or 0.68. Okay, that's how you use the complement. Now that's a far-fetched example, and you're not going to see it until a couple of sections from now, but that's how you use the complement. All right, so if I ask you what is the probability of one or more homes, and you have the probability of 0 homes, then you could just take the 0.32 away from 1, because the probability is always up to 1, and subtract it. So the probability of one or more homes is 0.68 or 68%. And that's how you use the complement. So remember the word complement. You're going to see it again, especially in the next 2 sections. You're going to see it again if the probability of this class failing is 68%, then you know automatically that the complement of 68% is what? 32%. So you know that 32% is going to pass. All right, that's how you use the complement when you're doing these kind of problems. All right, example, what is the probability of not rolling a 6 on a die? 5 over what? 5 over 6. Why? Because The probability of rolling a 6 is what? 1/6. So not rolling would be complement. You have to get used to thinking like that when you're doing complements and probability, because sometimes it'll save you a whole lot of work. Instead of calculating the probability of 1 and adding it to the probability of 2 and adding it to the probability of 3 and so on, all you got to do is take the probability of 0 and subtract it from 1. So that's how you use a complement. Complement can save you some time and calculations. Okay? So that finishes pretty much, whatever section that was. What was it in the book? 7A. So now we're going into 7B. 7B probably, and 7C probably goes over the additive and the multiplicative law. So we'll go ahead and talk about the additive law. And when do you use the additive law? Well, you use the additive law when you see the word or. Now, I don't mean or in the first couple of sentences of the paragraph. I mean at the end of the sentence, it'll say probability of O positive or O or RH negative, right? At the end of the problem, it's going to say, what is the probability of O or RH negative? And that's the or that we're talking about. When you see that word or at the end of the problem, that means you're going to use the additive law. The other thing that you need to worry about with the additive law is always subtract the overlap. And that's the two things that you need to remember with the additive law. Usually, especially with me, I usually give my questions on the additive law in a table form. And I'll just make one up. RH negative, RH positive, O, A, B, A, B, and 1, 2, 4, 6, 12, 3, 11, and 2. Okay. Now, what if I want to know the probability of O? Well, that's real simple. First of all, we take the total, which there's 10, and then 11 is 21, 25, 29, 39, 42, 41. Somebody check me. Add them up. Tell me check it and make sure it's 41. Because I don't want to start the problem until somebody else jumps in the hole with me. 41. 41, okay. And how many are O? 13. So that's pretty simple. But I didn't ask you something or something. I just asked for the probability of. So if somebody asks you the probability of something, you just do what you've been doing, taking the number that you know over the number attempted, or the total, and that's it. What about the probability of B? If I did the probability of B, that would be 15 over 41. Again, I'm just asking probability. So these two types is, what chapter is this? No, it'd be A. What chapter? 7A. So these two questions technically are 7A. Because I'm not asking you anything about the additive law. All right? But if I was to ask you, I would say, what is the probability of O or A. And there's your or. You see that or right there, or you see it, it'll be the probability of O or A type, whatever. There's your or. So we know that the total is 41. And we're going to focus on the O and the A. Here's the O, which is 13, and 5. So that'd be 1, I'm going to do this, 1 plus 12 plus 2 plus 3 minus the overlap. Well, is there an overlap? You see the overlap of anything? No, so you don't have to worry about it. So that's going to be 13 plus 5 minus 0 over 41, which is equal to 18 over 41. Okay, so that's how you do that for that. So let's do one now. And I'm going to ask for the probability of, and I'll do it in green to keep it separate from this, but I'm going to erase this one. Probability of RH negative or B. Here's the order. I'm going to take my handy dandy highlighter. I'm going to use blue. And I'm going to do my RH negative. And then I'm going to take my other highlighter. I'm going to color it something different, green. And I'm going to do my B. Now I'll take my blue marker and I say 1 plus 2 plus 4 plus 6. Put that in parentheses. And this black. Plus, I'm going to take my green marker and I add 4 plus 11. And then I take my red marker and I subtract what? My overlap. And my overlap is 4. All over 41. I have taught probability for a good while, and I have found that the little overlap with the highlighters works the best. So I've tried different ways of teaching it, and this is the best way to do it. If there's no overlap, you don't what? You don't worry about it. If there's an overlap, then make sure you subtract. And 10 plus, that's 13, plus 4 plus 11 is 15, minus 4, over 41, and 13 plus 15 is what? 28, 28 minus 4 is 24. And that's how you do the additive law. Pretty simple. Let's do the nerd. Like I said, today's going to be a short class. So you can complain. No, you can't complain on boss. She's not at work today. So for that one person that's going to, well, I really wanted to go over 3 sections of math today. Well, I'm sorry. Just SOL. I'm going to give you a table. It's going to be just like the table we just did with different numbers. And RH negative, RH positive, and what, B? What is it? OAB, OAB. 2, 1, 15, 12, 10, 8, 6, 4. I want to know the probability of RH negative, RH negative, or A, or AB. So take off. Use your handy dandy highlighters. Okay. Let's see, 15, 15 is 30, 40, 54, 58. Somebody check me. 58. We got plus, yeah, plus this, and then minus, overlap. I have to change all these colors for y'all, because everything's for y'all. Everything is for y'all. You can only complain. 15, I can't see that. Plus 12, plus 10, plus 2. Okay, 15 plus 12 plus 10 plus 2. Orange or blue, we'll do like that. So you can see more. 12 plus 6. Come on, we're not going to complain. I've already done it for you. 2 plus 1. And then I'll do the overlap in red minus the overlap. And the overlap is going to be 12 plus what? 2. And I don't see how it can be any more simple than that. So, 25 plus 24 is 49. Somebody check me. Plus 18 plus 3 minus 24 minus 14. Now, could you do some canceling? Yes. Now that I've shown you what we're doing, you could actually cancel this 14 and this 18, and that'll leave a 4. And that'll be 49 plus 7, which is 56. Somebody check me. Somebody check me, is that right?
That's what I got.
Okay, I said 49, and y'all said, yeah, that's right. Thank you, appreciate it. Appreciate you lying to me.
No, I didn't do the problem. I didn't do the problem lady did.
I didn't do it. Bush did it. 39 plus 7 is 46. How about 46?
That's right.
Now, go ahead, Hubert. Go ahead, it's fine. And that's how you do the additive law. I don't see how much more complicated that can get. I mean, I've had good luck with the little highlighter thing. Works out good. Anybody got a question on that? So I covered it so well that you don't have a question. Okay. I'm just amazing. Now the multiplicative law. The multiplicative law, I don't think I make up these words, but I don't. The multiplicative law is surrounded by the word and. Oh, red. Red, please.
To me, it's like the backwards. The addition should be and.
I know. What?
I said, to me, it's like the backwards.
I know. The word and means multiplicative. So when you see the word and, it means multiply. Unless I'm telling y'all wrong. As you look in the book, make sure I didn't get confused.
No, I know you're right on this.
Okay. All right. I was getting a question myself. So when you see the word and, make sure you use the multiplicative law. And you need to make sure where before you subtracted the overlap, here you need to designate whether it's with replacement or without replacement. Think of a bag of marbles. Bag of marbles has 5 red marbles, 4 blue marbles, and 5 green marbles. If you was to take one of those marbles out and put it in your pocket, what would that be? With or without replacement?
Without.
Without replacement. And what would it do to the outcome of the next draw? Would it affect it or not affect it? It would affect it if you put the put the marble in the popper. So, which one affects the outcome? Without replacement affects the next draw. And I'm not an English person. I can't remember if it's affect or effect. I think it's effect. Okay? That affects the next draw without replacement. Now they give you a word for that, either dependent or independent. I don't worry about the words. All I want you to know is it affects the next draw, because it affects the probability of the next person drawing. That's what I want you to learn. Now, how do you use the multiplicative law? Well, with replacement, we're going to use exponents, because you just multiply the same thing over and over again. Without replacement, you're not going to use exponents, you're going to use fractions. So let's take, for example, this bag of marbles. Let's say that I want to know the probability of picking a red marble the first 2 times that I pick. Red first 2 times. In other words, I'm going to take 2 reaches into the bag, and I want to know what the probability is that each time I pull out a marble for both reaches. It's going to be with replacement. Now, what's going to tell you with or without replacement? The directions, the test question, it's going to be given. So, how many times we're going to reach into the bag? Twice. So we've got 1 times 2. How many red marbles are there in the bag?
9.
Out of?
14.
And I put the marble back in, and I pick again 5 out of 14. So that is my probability of picking a marble, a red marble, the first 2 times that I draw. So that's going to be 5 to the 14th power raised to the 5 over 14 raised to the what? Second power. The 2 reflects how many times I draw. Now that's how you do multiplicative law. But what if I say without replacement? Without replacement means that when I pick that first marble, I'm going to put it in my pocket. So that's going to be 5 over 14. Well, if I put one of the marbles in my pocket, how many are left in the bag?
13.
And how many of the red marbles is left? 4. Remember, I'm asking, what is the probability of picking 2 red marbles the first time? First 2 times. And then you multiply 5 times 14, 5 times 4, you get 20 over 14 times 13, 14 times 14 is 196, 182. So that's your probability of picking a marble without replacement, with replacement, not without. See, what did we do at the top? We just took and multiplied it by itself, raised it to the second power. Here, we had to multiply the fractions. Now, somebody give me 5 over 14 and raise it to the second power. What do you get? Give me 4 decimal places. Point 0255. Now, do 20 over 182. Tell me what you get. 4 decimal places. That don't look good. Do it again. 20 divided by 182. That should be closer than that. Huh?
It's the same thing, I got it.
What? Okay, somebody take a calculator and take 20 and divide it by 182 and tell me if that's right.
That's what she's got.
Okay, that's what I need y'all to say.
Yes, I said
Speak
that.
up!
I said that. You could actually round back to 1099.
All right, but check this one.
I did. That's what I got.
Well, they shouldn't do that. Well, the small numbers, and that's what I'm fixing to tell you. The smaller the number, the more of a difference you're going to see here. So what does that mean on the other end? The smaller the number, that will be a big difference. So what does that mean on the other end?
Bigger than the rest of
The
it.
bigger the number, the smaller the difference. I'll show you here in just a minute. So what do you mean difference? Well, you did this one a certain way, you did this one a certain way. If we was to have 4 or 5 digits, you was to have 500 red marbles, 400 blue marbles, and 500 green marbles, then it wouldn't matter which method you used. Okay? Let me show you. Let's say this is 500. 500. Really? $400 and 500. Now do the same calculation. First two. See what you get. Okay, so instead of 182, and 14, what's this going to be? 1400? Okay, so we'll put 1400 right here. I'm not changing color because it takes an act of Congress to change the color on these pens. And this is going to be 500 and 500. So take 500, divide it by 1400, and raise it to the second power. See what you get. Should be the same. Shouldn't it? Okay. Now, do this one, except this time, instead of 14 and 13, what are you going to have? 1400 and what? 13 what? Now do that. Let's wipe this off. Tell me what you get. $13.99. What comes if you pick one marble out of 1400? How many's left? That's all. No, it's not pretty bad. So what do you get? Point what?
I got one something.
No.
Oh, I did it wrong then.
You're going to have 20 over some VA number. It's not going to come out to be 1 unless it's scientific notation. What does it get? Okay, y'all don't know how to use your calculators. Hold on just a second and let me. Now, you might have got scientific notation. No, forget it now. I asked y'all 3 times and y'all didn't give me any answers. So I come over here, and as soon as I pull up the calculator, gloriously y'all start coming up with answers. Just be quiet. If I didn't come over here and got on the calculator, just be quiet. Don't say nothing.
There's no way that I did it wrong.
No, you are wrong. So 20 divided by, you think you're going to pass this class.
I know. We'll have an A.
No, you're not. $1,400 times $13.99. Everybody with me? Okay, so that's 0.5. So it'd be 1, 2, 3, 4. So that's like 0.0001. Is that what y'all come out with? All right, so let me look. I don't think we did this one right. 500. It shouldn't be, no, because it's being multiplied by itself. It's not going to be the same. So that's going to be 500 squared divided by, parentheses, 1,400 squared and that's equal to 0.1. See, still that should be something wrong. Yeah, it should be, they should be about the same. Okay, I don't know why they're not the same. They should be about the same. I'll show you with the next problem. But that's how you do additive multiplicative all. Let me go to the next problem and I'll show you what happens when I make up stuff. Don't make up stuff. What? Okay. For which one? For the top with replacement or without replacement? Without replacement, what'd you get? Okay, good. I must have done something wrong. See, they get a little bit closer than 0.2 versus 0.1. The higher the numbers, the more they're going to be close to each other. And mine, I don't know what happened there, but anyway, I'm going to show you a problem you're going to see on the test. Here's the problem you're going to see on the test. You got a crate, and that crate has 4,500 CDs in it. And by past experience, quality assurance has told you that 20% usually are bad, okay, out of that crate with 4,500 CDs in it. Now, your quality assurance team, usually when they go through and check a stack, they will pick 3 CDs out of every stack, out of each crate or whatever, out of each batch, without replacement. And if the 3 are good, if they're all good, then you send it out. So, what is the probability for this crate to get 3 good CDs? Basically, you're the quality assurance person. In comes a batch of CDs. You go and reach into that CD bin and you pick 3 out. If those 3 CDs, you go back, take it back to the lab and you test them. If they're good, you send it on to Walmart or Target or whatever. If they're bad, then you say, okay, something's wrong. And you go back and you talk to the people that made it. Okay? So, what is the probability that all 3 are good CDs? Well, first of all, you got to know how many is bad, projected. So, what's 4,500 times 20%? You don't need a calculator for this. It's 900. So 900 of these CDs are projected to be what? Bad. Therefore, what's the complement of 900 to 4,500? Good. 3,600 are what? Good. Now, what is the probability without replacement? Without replacement means that you're not going to replace it. You're going to put it in your clipboard. You're going to take it back to the lab. So that means, parentheses, times parentheses times parentheses. You know the total is 4,500. Oops, wrong direction here. 4,500, but each time we take one out, 44.99, right? And 44 what? 98. Now, how many are good? So 3,600, 35.99, and 35 what? All right, do that math. Give me 4 digits. You receive blank CDs. So that way you can't complain about which payment I take. Yeah. These are those CDs that you used to be able to record on. People don't do that now. What is it? Point what? Okay, what'd you get? 0.5119. All right, I'm gonna wait till somebody seconds that. You second that? 5, Miss Nick, sorry, Miss Bess.
I'm not that far into it. I was still trying to figure out what I did wrong on the other one. I figured it out though.
Still don't say it. Now, what if I decide to just say, I'll bump it? 3,600 over 4,500, raise it to the third power. I'm gonna do it the easy way. So take 3,600, divide that by 4,500, and raise it to the third power. What do you get? For 5,1 what? Is it 5,120 or is it rounded? Okay. What if I tell you to round to the third digit? It's the same. So the whole point of me showing you this is the higher the numbers, you have to worry about doing the different method. No. And I would say probably over 300. You're talking about X being above 300. Anything below 300, you're going to see a difference in that third or fourth decimal point. Okay? Anything below 300, you're going to see a difference. What do you think? Let's do one more just so you'll, because if I put a CD problem on there, it's going to be on the test, I guarantee it. But I'll do one more. Let's do, thing old 5,000 CDs in a batch, and 15% are usually projected to be bad. What is the probability of picking 5 good CDs without replace? Do it both, with or without replacement. So 5,000 are in there, so that means 500 and be 750. 750 are bad. So therefore, if 750 are bad, that means what? 250, 40, 250 are good? Somebody check my math. I mean, you should be able to do that in your head. Or you can sit there and wonder what the 6 cents is for. Good. Now with replacement, move it over here. Means that when we pick a CD, we're going to put it back, which you would not do that with a quality assurance. Why? If you were working quality assurance, why would you not do with replacement? Why? Huh? Because you may have a bad CD, you may be putting it back, which multiplies your bad reading, or if it's a good CD, you're putting it back, which could give you a false indication of the good CDs. So when you're doing quality assurance, chances are they're never going to be with replacement. But I'm not trying to show you that right now. I'm trying to show you that it doesn't make a difference because of the numbers are so big. So with replacement, we want to pick 5 good CDs. So that's going to be 4250 out of 5,000 times 4249 out of 4,999, 4248 over 4,998. Yeah, I was going to say without replacement, sorry. I did it fast backwards. 4247 over 4997 and 4246 over 4996. That's without replacement, or without replacement. Now with replacement, that's what you wouldn't want to do. But it's easier because what do you do then? 4250 over 5,000 raised to the what? Raised to the 5th power. So somebody give me without replacement 4 digits, and somebody give me with replacement the 4 digits. With is what? 4437. 4435 raised to the 3rd digit. 4444. So the main point of today is to show you the additive law and the multiplicative law, and to show you what you need to know for both and what you don't need to know for both, and what's okay for both, and all that good stuff. Because what I want you to do today and tomorrow is work on, which section are these? 7B and 7C? Is it B and C or C and D? Or B and D? Is it skip or? Okay.
It's not A.
Okay, so 7A is probability. 7B is your additive law. And 7C is multiplicative law. And probability, read, and heed. And additive law, you got to make sure you're dealing with the word what? Or. And you make sure what? Always subtract the what? Overlap. And with the multiplicative law, you've got to remember the word is what? And you've got to remember whether it's with or what? Without. No, I can't spell that. Hold on. Without replacement. And doesn't matter with 3 or 4 digits. The higher the digits, the less it matters. Okay? So that's what you should be doing right now for homework. You should be working on those 3 sections, and I expect for questions to be sent for Wednesday because this is kind of a introduction. I don't want to teach all period day. Okay? So if you're going to complain, like I say, you can complain to my department head, but she's not working today, so you can just wait. Hold on just a second. Let me get the roll, and I'll let y'all go.